I love robotics. I've had a passion for robotics and Rubik's Cubes for a long time, and this summer I decided, why not combine them? So I set out to build the EV3 Cuber, made from LEGO Mindstorm's parts and made to solve a 3x3x3 Rubik's Cube. I decided to build it for fun, and I thought it'd be cool if I had a robot that can solve a Rubik's Cube for me. It was built by David Gilday, and it's made to work on the EV3 or NXT sets. This process was super fun, and I recommend it to you too. Today, I'll be showing you how it works, what parts it has, as well as some failures that I encountered and solved. Let's get right to it. Here's a video of Mindcuber in action solving a cube. So to make this all work, there has to have multiple parts working together to solve the cube. So first there is the flipper. The flipper flips the cube 90 degrees so it can turn it at a different angle. It's powered by a large motor and it grabs the cube, tilts it back, then pushes it forward with the cube flipping itself along the way. The second part is a color sensor motor. This is a motor that powers the arm that moves the color sensor back and forth when scanning each of the colors. It is powered by a medium motor. The final motor is the cube turning motor. This is probably the most important part of the robot, because this is the part that turns the cube and allows for the robot to solve it. It turns only the bottom layer, and as you saw in the video, the flipper holds the top two layers while the bottom one is being turned. It's powered by a large motor. Now, on to sensors. There are two sensors used on this robot. The first one is the color sensor. That's the sensor that scans each face of the cube and detects the colors. These colors are then imported back into the machine to turn into moves that the robot needs to do to solve the cube. The sensor gets the RGB value of each color, determining the color of each individual square. So the sensor starts with the center square of each face, and as the cube turner motor moves around, it goes around and scans each face along the edges and corners. The second sensor is the infrared sensor. That's the one that looks like a little eye on the back of the robot. So this sensor doesn't serve much purpose in solving the cube. This one can detect whether the cube is there or not. At the beginning of the scanning process, the sensor will first detect if the cube is there or not. If it is, then the process can continue. But if it's not, that means the cube is not there, so it will wait until it detects a cube. Finally, we have the brick. The brick is a giant thing in front of the robot with the screen and the buttons. The brick tells each sensor, each motor what to do, when to do them, how to do them, everything. So that's basically the mastermind of the robot. Now, after all these motors and sensors and electrical parts, then we have the mechanical parts. We have the arm that connects to the color sensor, which is able to move the color sensor back and forth just by the turn of a motor. Then we have the box, which the cube sits in. It's made to fit the cube perfectly. because if it didn't, then it wouldn't turn. Then we have the entire structure of the robot, which is made to give support as well as house a few motors. Finally, we have the 4 wheels at the bottom, which is made to keep it stable. So through this process, I also encountered a lot of failures, setbacks, and more. A lot of times, it was the flipper that was having problems. Either the flipper was not flipping enough, and the cube was just landing right back where it started, or the flipper was going too much overboard, and when it came back, it hit the cube and got jammed. Here's an example. I'll dive deeper into my failures as well as modifications I made in the next video. Overall, this was a really fun learning process. This video is only part 1 about the Mindcuber. I'll dive deeper and explain more about failures and modifications, the code, the building process, and so much more in the next video.